Hello, in this video I'm going to show you how to find probabilities for a normal distribution, and we're going to use technology and we're going to use a website called OnlineStatbook. Okay, so the link is right here, and it's also in D2L, or ask your instructor for the link. You can also just go to OnlineStatbook.com. So as we saw in the last video, we were finding probabilities with the empirical rule, but remember this is approximate. 68%, 95%, 99.7%, those are all, that's just an approximate guideline. Okay, so we want to find them exactly. Okay, so I'm going to go over to OnlineStatbook, and here's what it looks like at the top of the page. And this one finds areas under the normal distribution. So what you're going to do is type in your parameters, your inputs. So we are going to find the exact probabilities that we approximated in the last video. So that was our annual rainfall in Portland. So our mean was 40 inches. I'm going to type that in. And the standard deviation was 8 inches. And the thing that I love about this website is it labels the normal distribution correctly. It puts the mean in the center, and it has 3 standard deviations on each side. You can also find these probabilities with Geogebra, but it doesn't label the scale correctly. So if you're going to copy and paste an image for an assignment, a report, project, anything like that, be sure to copy from this website and not from Geogebra. Okay, so let's go back to our worksheet really quickly here. So we're going to find the exact probabilities for example 1. So example 1 was the probability that x was between 32 and 48. Okay, so let me switch back over there. Once you put in your mean and standard deviation, you can see you have all these options: above, which is greater than or equal to, below, which is less than or equal to, between 2 numbers, or on the outside of 2 numbers. So in this case, we're doing between, so I'm going to click on that one. And then we wanted between 32 and 48. When I hit enter, it updates the image, which is great, so you can copy and paste that, and it gives us our area right here. So it's 0.6827. So you can see the 68 rule is approximate. It's actually 68.27%, but that rule is complicated enough without having all the extra decimals in it. Okay, so let's keep practicing. I filled that one in. Now B was more than 48 inches. And remember, equal or greater than or equal is the same mathematically with a continuous distribution. So this time we're going to click on above and type in 48 and enter, or click somewhere else, or click on recalculate, and it will calculate that for you. So there's the picture. I love having the visual because it's just a good double check. You know it's got to be on the right side. So I know I've done the right probability, and it's 0.1587. We got 0.16, so again, pretty close. Okay, part C was less than or equal to 24. So I'm going to do below this time, 24, and we get 0.0228. Last time with the approximate empirical rule, it was 0.025. So close. D was, what's the probability that the rainfall is 56 inches or less? x less than or equal to 56. So stick with below, 0.9772. And E, remember, E was the one we couldn't do with the empirical rule because it's between two standard deviations. So now we can do this. Probability that the annual rainfall is 54 inches or less. It's a less than or equal, so I'm going to stick with below, and 54 is 0.9599. Okay, pretty cool, huh? So we can use this to find any probability that we need. Now, when you're doing your homework, just be sure that you look really carefully whether it's asking you to use the empirical rule or not. Because if it's asking for the empirical rule, then these would be the correct answers, and they're approximate answers. So if you use technology and get the exact answer, it won't be marked correct if it's looking for the empirical rule. Okay, so just read really carefully on your homework, quizzes, tests, whatever. And I want to show you Geogebra really quickly because some of you, well, you've probably used it already for the binomial distribution. So if you like it, you can keep using it. I'm going to click on Geogebra Classic here, and then I'm going to click on Probability. There's nothing wrong with using Geogebra, but see what I'm talking about with the scale here? The scale is just random numbers at the bottom, and if I resize my screen, it changes the numbers, so it doesn't label the standard deviations properly. But let's just do one of these. So if you're not copying and pasting images, you can use it as a calculator just fine. So let's put in our 40 and 8. And let's say, oh, it just came up because that was one standard deviation on each side, 32 to 48. So you would, for this one, you would use the left bracket if you wanted less than, the middle brackets if you want between two numbers, and the right bracket if you want greater than. Okay, so this one happened to be between 32 and 48, and it came out to the same number, 0.6827. If I go to the left-sided, then it just gives me one number to type in less than or equal to. If I go to the right-sided, it just gives me one number to type in for greater than or equal to. Okay, so you're welcome to use this. Just don't copy and paste these images because they don't look great. Okay, so let's do one more example on this. Everything we've done is with this rainfall example. So let's do a new example. In a medical study, the population of children in Wisconsin were found to have serum cholesterol levels that were normally distributed with a mean of 1.75 milligrams per milliliter and a standard deviation sigma of 0.3 milligrams per milliliter. Define and draw the normal model for children's cholesterol in Wisconsin. Okay, so remember define, that's how we define in symbols. X is distributed as normal, and we put in our two parameters. So we put in our mean and our standard deviation. So 1.75, comma 0.30. When you show this, it tells me what you're putting into the technology. So it's a way of showing your work, and it's just the way that statisticians define the model that we're using. Okay, so now let's draw it. I'm going to draw my axis and just draw a rough curve. You'll get practice at drawing these. And then I'm going to put the mean in the center, and I'm going to evenly space 3 tick marks on each side. Remember, we label 3 standard deviations on each side. So 1, 2, 3, 1, 2, 3. Okay, and we put our mean in the center, 1.75. I'm going to scoot this up. calculator on here. Okay, so I'm going to do the shortcut for the standard deviation. So 1.75 plus 0.3 enter plus, whoops, plus 0.3 enter, okay, screwed it up. 1.75 plus 0.3 enter plus 0.3 enter plus 0.3 enter. Okay, so that gives me my three values to the right of the mean. So they are 2.05, 2.35, and 2.65. And then I'll do the same thing with minus. So 1.75 minus 0.3 enter, minus 0.3 enter, minus 0.3 enter. So going down is 1.45, 1.15, 0.3 is kind of nice on the math also, 0.85. Okay, and I want to label this axis. So this is children's cholesterol levels in Wisconsin, and the units are milligrams per milliliter. Okay, so that's how we define and draw the distribution. This shows people what we're talking about, what normal model we're dealing with. Okay, now we can use this to find some probabilities. So part B says a child has a cholesterol level of 2.11 milligrams per milliliter. What is the percentage of children in Wisconsin who have cholesterol levels that are higher than this child? Okay, or child's. So we want to do the probability that X is greater than, higher sounds like strictly higher, but remember it doesn't matter mathematically. So let's go to OnlineStatbook. Switch back over to this one. Okay, so I have my old numbers in here. So let's go ahead and put in 1.75, and I'm going to try, can I use the tab key? Yeah, you can use the tab key to go to the different fields. So 0.3 tab, and now I'm going to click on above 2.11. Okay, now we could shade this in our drawing. The answer I'm getting is 0.1151. So I could shade this if I go find, okay, see where would 2.11 be? Somewhere closer to 2.05. So I could shade that, and that is 0.1151. Okay, this one's asking for a percentage, or 11.51%. So that does sound a little concerning, doesn't it? Only 11.5% of kids have a higher level, so that's a pretty high, that seems like a very high cholesterol level. Let's do another one. Find the percentage of children in Wisconsin who have cholesterol levels between 1.3 and 2.23 milligrams per milliliter. So this is between 1.3 or 1.30 is less than or equal to X, less than or equal to 2.23. Back over to OnlineStatbook. We've already got our mean and standard deviation, which is great. So we just switch to between 1.3 and 2.23. Check your drawing, or check this drawing, make sure it looks good. Looks like what we want, so it's 0.8784. 8784, or 87.84%. Okay, so that's how you find probabilities in the normal curve using technology. So you can do this for any mean and any standard deviation. So try it out, and I'll see you in the next video.